Hello, so today we'll be finding where the net force is 0 between two positively charged atoms, and our atom that we will be finding the net force will be 0, that one will be a negatively charged atom, and just looking at this we can see that our charge number 1 is 15 microcoulombs and our charge number 2 is 6 microcoulombs. And because of the charge difference, we do know that our little electric charged atom will have to be a little bit further away from Q1, just because this atom will be pulling it this way more, so it needs to be further away. And we already know that the further away an atom is, the smaller the force, magnitude of the force. And where the net force is 0, we're basically just looking for where, at what point in this 2 meters do the two force vectors equal out. So on this side we will have one going this way, and this one is the force of 1 on 3. Oops. This is our charge 3. And then we will have one going this way. And this one will be our force of 2 on 3. And we want to find when these two are equal. And just to kind of simplify things, we will kind of label a little bit more of these. So from charge 3 to charge 2, we will label that X. And then from charge 3 to charge 1, we can label that 2 minus X. And we're labeling it 2 minus X because it is this 2 meters down here minus this X. And then we get this. And that is one quantity. And we have our formula right here. So our formula right here, the electric force, that is just solving for the magnitude of our vector right here. So, and we want this to be equal to this. So we can just set this whole part equal to itself, and we will change the variables out because one side will be charge 2 and 3 versus charge of 3 and 1. So when we add it all into our formula, the formula that I'll be following will be our KE times our times our Q, our charge 2, and then we'll do charge 3, and then our radius, which is our distance between them, between 2 and 3, we have our X, and then that's squared, and we have it equal to KE still, and we will have our same charge number 3, and this time we will have charge number 1. And then that will be all over this right here, 2 minus X, and then you square the quantity. And once we have this formula, we can kind of simplify it a little bit. So, since we do have our Coulomb constant on this side and on this side, we can cancel them. And then we can also cancel out our charge number 3's. And once we do that, we can do our cross multiplication. And once we do our cross multiplication, we should get our Q, wrong color. we should get our Q1 over our Q2 equals our 2 minus x quantity squared all over x squared. And from here we can plug in the numbers now. And once we get our numbers, we will have the 15 times 10 to the negative 6 all over 6 times 10 to the negative 6 equals 2 minus x quantity squared all over x squared. And from here it should be just algebra. So we will take the square root of the whole thing, and on this side we will end up with 2 minus x over x. And this whole thing you can just plug into a calculator, and once you plug it in you should get 1.581 times 10 to the power of negative 6. And from here it is still just algebra. We can multiply out that x on both sides, which gives us 1.581 times 10 to the negative 6. X equals 2 minus x. We add 1x to both sides, which then gives us 2.581 times 10 to the negative 6, x equals 2. And then once we get there, we will just divide both sides by the 2.581 times 10 to the negative 6. And from there, we should get our x to equal 0.775 meters. And just to double check that, that is our x right here, so that is 0.775 meters right of our Q2. So that is our answer.